So hello friends, let's continue with our question solving class. So question number 41 says the ratio of volume of air voids to the volume of voids, that is VA by VV. We call it as air content. Yes, so air content will be the correct answer. For a perfectly dry soil mass, the degree of saturation is 0. Of course, yes, for a perfectly dry soil mass, the degree of saturation is always 0, and the degree of saturation is 1 for perfectly wet soil mass. Yes, jetia pani di bhori jay tetia ami degree of saturation 1 boli kau. Yes, so question number 42 is A. So question number 43 says the difference between maximum void ratio and minimum void ratio of a sand sample is 0.3 if the relative density of the sample is 66.6% at a void ratio of 0.4, then the void ratio of this sample at its loosest state. So here we have to find the void ratio at its loosest state, that is Emax. We have to find the Emax. Given is dr is given. Yes, dr is given how much? Dr is given relative density 66.6%. yes, 66.6%. Emax is given. Emax is given how much? That is void ratio, that is minimum maximum void ratio is given 0.3, minimum void ratio. The difference between maximum and minimum void ratio is given. Emax minus Emin is given. Yes, difference between maximum and minimum void ratio is given, that is Emax minus Emin is given. Emax minus Emin is given how much? 0.3. 0.3. yes, so Emax minus Emin is given 0.3 and the void ratio at void ratio 0.4, that is E is given 0.4. E is given 0.4. Then we know, what do we know the formula? We know the formula is dr is equal to Emax minus E by Emax minus Emin. Yes, Emax minus E by Emax minus Emin. So we can directly put here dr is given how much? 66.66. 66.6% is equal to how much? 0.3 is the Emax minus Emin, and here it is given we have to find the Emax. Emax minus E, that is 0.4. yes, 0.4. On solving this we have Emax is equal to how much? On solving this we have Emax is equal to 0.6. So the correct answer will be B, that is 0.6. okay, so the correct answer will be B, that is 0.6. Always remember the formula for relative density is Emax minus E by Emax minus Emin. Emax is the void ratio at loosest state. Emin is the void ratio at densest state. Why? Because at loose state, when the soil is at its loosest, then the voids will be more. That's why it is the Emax. And the densest state, the voids would be minimum. That's why it is Emin. When it is called Emin, it means it is in the densest state, and when it is called Emax, it is in the loosest state. Always remember this. Okay, so the next question, the dry density of a soil is 1.5 gram per cc. If the saturation water content is 50%, then its saturated density and submerged density will be respectively. So dry density is given, gamma D is given. Okay, gamma D is 1.5 gram per cc, 1.5 gram per cc. okay, gamma D is given. Then saturation water content, that is S equal to 1 is given. Yes, S equal to 1 given, small w is equal to 0.5 is given, small w is 0.5 is given. So what we have to find is saturated density and submerged density. We have to find gamma set and we have to find gamma dash or gamma sub. Okay, solve this and write your answer on the comment box. Okay, solve this and write your answer on the comment box, everyone. Find the answer and comment on the answer box. Will it be A, B, C or D? Okay. So question number 45, a soil sample is having a specific gravity of 2.6 and a void ratio of 0.78. A soil sample is having a specific gravity of 2.6. Specific gravity is given 2.6, Z equal to 2.6. Void ratio is 0.78, E is equal to 0.78. Yes, the water content in percent required to fully saturate, S is given as 1, fully saturate. So we know ES equal to WG. Solve it. If we solve it, so the answer what will come? We have to find S is equal to 1, E is equal to 0.78 and G is equal to 2.6. We have to find the value of W. What is the value of W? So after solving, we find that the value of W is 30. Okay, that is 0.3, that is 30%. Okay, so the next question, the specific gravity, question number 46, the specific gravity of a soil is the ratio of unit weight of solids to that of water at a temperature of 27 degrees centigrade. This is the standard temperature. Okay, a dry soil sample weighing 100 gram has a volume of 60 ml and specific gravity 2.5. Its void ratio is. So the next question 47, a dry soil sample weighing 100 gram, that is dry soil sample, that is weight of solid is given 100 gram. Yes, has a volume of 60 ml. Volume is given as 60 ml. Yes, 60 ml, that means we can write this as 60 centimeter cube. We can write this as 60 centimeter cubes or 60 cc. So therefore its density is 100 by 60 gram per cc. Yes, we can write this as 100 by 60 gram per cc. Yes, so from here we find that gamma D or dry density is 100 by 60. Yes, so gamma D is equal to 100 by 60. Okay, so G is given as how much? 2.5. G is given as 2.5. Yes, we have to find E. Okay, we have to find E. Okay, let me remove this. So you know the formula, G rho W by 1 plus E. Yes, from here if we solve, we have to find the E. If we solve, we will find that E is equal to 0.5. Okay, if you solve this, we will find this as E is equal to 0.5. So answer will be B. Okay, okay, so moving on to the next question. For a given soil mass, the void ratio is 0.6. The void ratio is 0.6. For a given soil mass, the void ratio is 0.6. Water content is 18%. Water content is 18%, that is 0.18. We can write. Specific gravity of the soil is 2.6. This is very easy. Specific gravity of the soil is 2.6. Degree of saturation, S, we have S equal to Wg by E. Solve this and write the answer on the comment box. Okay, so question number 49, the ratio of the difference between the void ratio in its loosest state and its natural void ratio to the difference between the void ratio in its loosest and its densest state is, it is called density index or relative density or degree of density. So we can write the answer as D. Okay, so question number 50, the submerged or buoyant unit weight of soil is equal to the dash of the unit weight of saturated soil and unit weight of water. We have submerged unit weight is gamma saturation minus gamma W. So you can say this as difference between the saturated unit weight and unit weight of water. So question number 50 answer will be B. Okay. So the next question, the water content is the ratio of weight of water to the weight of solids. Yes, this is true. The void ratio of a soil is defined as the ratio of the void ratio of a soil is defined as VV by V as volume of voids to the volume of solids. Yes, volume of voids to the volume of solids, total volume of voids to the total volume of solids. So the answer will be C. 52 answer will be C. Yes. Question number 53. The water content ratio of a soil is defined as the ratio. The water content ratio is defined as the ratio of weight of water to the weight of solids. Weight of water to the weight of solids. Yes. So that question number 53 will be A. The degree of saturation for moist soil is more than 50%. Yes. Okay. The approximate void ratio in sandy soil. The approximate void ratio in sandy soil is about 0.6. Okay. So the next question is, when the soil particles are less than 0.002 mm, the force of gravity on each particle is dash as compared to the electric surface charges. Okay. So question number 56 says, when the soil particles are less than 0.002 mm or when the soil particles are fine grained or clay soil. Okay. So we all know that force of gravity is negligible. All the forces are mostly electrical surface charges. Okay. So the answer will be negligible. Question number 57. Which of the following clay mineral gives the maximum swelling? Maximum swelling is given by Montmorillonite. The next maximum is given by illite and the lowest swelling is given by kaolinite. Okay. So the next question, gravel and sand is cohesive coarse grain soil, cohesive fine grain soil, non-cohesive coarse grain soil, non-cohesive fine grain soil. Of course it is non-cohesive coarse grain soil. Yes. Question number 58 answer is C. So the next question, the specific gravity of sandy soil. When we do the experiment, we find that the specific gravity of sandy soil is about 2.6 to 2.8. So we can write this as 2.7. Next question, which of the following gives the correct decreasing order of the densities of soil sample? So this is very important. Almost every exam asks this type of question. Important exam asks this type of question. So remember this, gamma S is the greatest. Yes. Then gamma set, then comes gamma T, then comes gamma D, then comes gamma submerged. So in a soil sample, unit weight of solids gives the greatest value, which is greater than saturated unit weight, which is greater than total unit weight, which is greater than dry unit weight, which is greater than submerged unit weight. Okay. So the answer here will be this. Okay. Saturated weight means here we will consider this as total, then dry, then submerged. Always remember this. Okay. Always remember this. So the next question, bulk density of a soil is defined as the ratio of bulk density of the soil, that is gamma T, is defined as the ratio of total mass of soil to the total volume of soil. Yes, total mass of soil to the total volume of soil. Yes. So the next question number 62, unit weight of soil mass is expressed in Newton per meter cube. Yes, kg per meter cube is for density, not unit weight. Unit weight is measured by or expressed in Newton per meter cube. The next question, the dry density of a soil is same as unit weight of solids. Dry density of a soil is same as unit weight of solids. No, the density and unit weight are totally different thing. Okay. So the next question, submerged soils are dash saturated soil. Submerged soils are fully saturated soil. The density of soil mass is expressed in kg per meter cube. So the answer is B, kg per meter cube. So let's continue to the next question. If the volume of voids is equal to the volume of solids, given Vv is equal to Vs, volume of voids is equal to the volume of solids, then the values of porosity and void ratio are respectively. The values of porosity and void ratio, the values of porosity and void ratio are respectively. So let's find out. We know porosity N is equal to Vv by V, that is equal to Vv by Vv plus Vs, that is equal to Vv by 2Vv. So Vv can be cancelled, that is 0.5. Yes, so N is 0.5. So naturally we have got the answer here as N is equal to 0.5. okay, porosity's value is 0.5. let's find out if E is equal to 1. okay, E is equal to Vv by Vs. so if Vs and Vv are equal, then of course E is equal to 1. so question number 66, answer is C. okay, question number 66, answer is C. Next question, if W is the water content and gamma is the unit weight of soil mass, then the unit weight of dry soil, gamma D, is equal to gamma by 1 plus W. Question number 67 also, answer is C. Question number 68, the relationship between dry unit weight and specific gravity, void ratio and porosity is, okay, we have, you see these two formulae are given equal. Yes, G gamma W by 1 plus E, G gamma W by 1 plus E. okay, so the next question, the unit weight of a completely saturated soil, unit weight of a completely saturated soil means S is equal to 1. yes, gamma set is given by G plus E gamma W by 1 plus E. 69 number A, answer. okay, the relationship between saturated unit weight, specific gravity and porosity, saturated unit weight, specific gravity and porosity is given up by G plus 1 is given by gamma set is equal to G gamma W into 1 minus N plus N gamma W. That is question answer on option number C will be the answer. okay, the submerged unit weight, that is gamma dash, will be G minus 1 gamma W by 1 plus E. yes, question number 71, answer will be C. The water content of soils can be accurately determined by, accuracy, if we want water content as accurately, then we will go for oven drying method. okay, for accurate determination we go for oven drying method. Question number 73, the specific gravity of soil solids is determined by pycnometer method, hydrometer analysis, sieve analysis, all of this. So question number 73, it is pycnometer method. okay, because with sieve analysis we find this gradation, yes, not specific gravity. According to pycnometer method, the specific gravity of soil solids is given by out of this following, the answer will be this m2 minus m1 by m2 plus m4 minus m1 minus m3. Okay. Stokes law is used to determine specific gravity of soil solids, density of soil suspension, grain size distribution of those soils which, yes, the answer will be number C, grain size distribution of those soils whose grain is finer than 0.075 mm. That is, for fine grain soil, if we want the grain size distribution, we use the Stokes law. Okay. So the next question, hydrometer analysis is used to determine the density of soil suspension. If press A if you agree, or tick B if you disagree. Okay, so we have to agree because this is true. The standard temperature at which hydrometer is calibrated. The standard temperature at which hydrometer is calibrated is 27 degrees centigrade. When the hydrometer analysis is performed, it requires correction for temperature, meniscus, dispersing agent. We need the correction of all of this. The correction is given by C is equal to Cm minus Cd plus minus Ct. Okay. The meniscus correction is always positive, the dispersing agent correction is always negative, and the temperature correction is either positive or negative. Okay. So the next question, according to Stokes law, the velocity at which the grains settle out of suspension, all other factors being equal, is dependent about. According to Stokes law, the velocity at which grains settle out of suspension, all other factors being equal, is dependent upon shape of the grain, weight of the grain, size of the grain, all of this. So it depends upon all of this. Okay. So according to Indian standards, the dispersing solution used in pipette method for the determination of size of particle consists of generally 7 gram of sodium carbonate, 33 gram of sodium hexametaphosphate, and 1 liter distilled water. So the answer will be B. Okay, remember this. Okay, so we will continue the next questions in our next video. Okay, thank you so much.